Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is complex numbers and solving quadratics day 1. The first thing here is the imaginary number I is defined as the square root of negative 1. So I equals the square root of negative 1. So if I equals the square root of negative 1, what would I squared equal? What would I squared equal? Well, let's look at that. The square root of negative 1 squared. What happens if I square a square root problem? The squared and the square root go away, so it would be negative 1. So I squared is just negative 1. All right? And so a complex number is written in the form a plus bi, where a is the real part and bi is the imaginary part. Basically, as we go through these problems, any part that has an I attached to it just needs to go at the end. Okay? So we need to simplify the radical expressions using the imaginary number. From here, what we're going to look at is how can I get rid of the negative under the square root? Well, from our last lesson, we know that anything under the square root can be written as two separate square roots. So I can have the square root of 64 and the square root of negative 1. From here, what is the square root of 64? It would be 8. The square root of negative 1 would be I, which we learned right up here. Okay? So my answer would be 8i. Okay? On to number 2. I have the square root of negative 121. Well, this could be the square root of 121 times the square root of negative 1. Again, if you have your square root list out, your perfect square root list out from the last lesson, you know that the square root of 121 would be 11. The square root of negative 1 is I. So our answer is 11i. On to number 3. This one's a little trickier. Okay? What I'm going to do, though, is I'm going to take the square root of 68 times the square root of negative 1. Well, I know that the square root of 68 is not going to be perfect because of my perfect square list that we have out. But what I can look for is something that 68 can be divided by that is on my perfect square list that will allow me to split that up and find a perfect square. So if you look through that list, you type a bunch of things into your calculator, what you're going to find out is I can break up 68 into the square root of 4 times the square root of 17, and that's still times the square root of 1. Well, what is the square root of 4? The square root of 4 is 2. Can I possibly find the square root of 17? I cannot, because 17 is not a perfect square. So I can get the square root of negative 1, though. So it would be 2i times the square root of 17, and I'm finished. Okay? On to number 4. I can split the square root of negative 300 into the square root of 300 and the square root of negative 1. Is the square root of 300 a perfect square? No, it's not, but I can break that one up pretty easy. That one should jump out at you if you have your list out. It would be the square root of 100 times the square root of 3 times the square root of negative 1. What's the square root of 100? It's 10. What's the square root of 3? Well, that will not come out perfect, so I can just leave that as the square root of 3. But what is the square root of negative 1? It's I, so 10 times I times the square root of 3, and I'm finished. On to number 5. I can break up the square root of negative 11 into the square root of 11 and the square root of negative 1. Is the square root of negative 11 a perfect square? No, it's not, but the square root of 1 or negative 1 is I, so it would be I times the square root of 11. On to number 6. This does not have a negative under the square root. So the first thing I want to try to figure out is 49 a perfect square? Well, it is. So the square root of 49 would be 7. I'm going to leave this negative out front, take the square root of 49. My answer would end up being negative 7. All right? On to the next section. We're going to solve the following quadratics using square roots. What I'm going to do here is, especially on number 7, I already have the x squared by itself. So I'm going to go ahead and square root that. So this would be x is equal to the square root of negative 4. I can break the square root of negative 4 into the square root of 4 and the square root of negative 1. What's the square root of 4? It's 2. The square root of negative 1 is I, so I am finished. On to number 8, I need to get that x squared by itself. So I'll subtract 16 from both sides. That would give me x squared is equal to negative 20. I can square root both sides now so I can get x by itself. So x would equal the square root of negative 20. Can I break up the square root of negative 20 into a perfect square and a non-perfect square? Yes, I can. So x would equal the square root of 4 times the square root of 5 and times the square root of negative 1 because that was a negative 20. Moving on, what's the square root of 4? It's 2. Is the square root of 5 perfect? No, it's not, so I can leave that as the square root of 5. But the square root of 1 is I, so it would be 2 times I times the square root of 5, and I'm finished. I understand these are abstract, but the sooner you realize that anytime I'm trying to take the square root of a non-perfect square, I either need to break it up into perfect square and non-perfect square, or it's just going to stay the square root of the number that is not a perfect square. On to number 9, I'm trying to get x squared by itself, so I'll subtract 10. That will leave me with 2x squared is equal to negative 24. Divide by 2, divide by 2. X squared is equal to negative 12. From here, I can take the square root, so x would equal the square root of negative 12. I can rewrite the square root of negative 12 as the square root of 12 times the square root of negative 1, right? Those are all things that we've done in the past. Hopefully you're starting to catch on to those. Now, is the square root of 12 perfect? It's not, but I can break 12 into the square root of 4 times the square root of 3 times the square root of negative 1. What's the square root of 4? We've talked about that numerous times. That's 2. Is the square root of 3 perfect? No, it's not, but the square root of negative 1 is I, so I can do 2I times the square root of 3. And I'm finished there. On to the backside. Now we need to add or subtract the following expressions. We have two imaginary numbers are considered to be like terms and can be added or subtracted following those rules. So anytime that I have something like 21i plus 3i, it would add together to make 24i, just like I would treat it just like it is an x. All right, I would treat it just like it is an x. Remember that our form, once we write our answer, will be a plus bi. So anything that has an I in it will go in the back. All right. So let's look at problem number 7. I have 21i plus parenthesis 8 minus 9i. Well, according to order of operations, what I have to do is try to combine what's inside the parentheses first. But since 8 does not have an I, there is no way that I can combine 8 and negative 9i. So all I'm going to do in this case is just drop my parenthesis. That would leave me with 21i plus 8 minus 9i. From here, I need to combine like terms, so it would be the 21i, the negative 9i. Well, 21i minus 9i would get me positive 12i. Positive 12i. Remember, anything that has an I attached to it will go in the back, and we are finished. Number 8, again, I'm going to look inside the parentheses first. 2 plus 5i, I can't do it, so I'm just going to drop my parenthesis. Plus 4 plus 3i, again, I'm just going to drop my parenthesis. From here, I can combine like terms, so I can add the 2 to the 4. That would get me 6. I can add the 5i and the 3i. That would get me positive 8i. And I am done because I cannot add 6 and 8i together. Number 9 is a little trickier. I have a negative in front of this parenthesis, which means that I have to distribute a negative 1 to both of those pieces. But that front parenthesis, there's nothing inside I can do, so I can just drop my parentheses. Since I distributed, all my signs will change. So I have 6 plus 17i minus 18 plus 9i. I could again combine like terms, so it'd be 6 minus 18, which is negative 12. I can do 17i plus 9i, which would be positive 26i, and I am done. Because again, I cannot add negative 12 and 26i. Number 10, negative 30 plus I. Is there anything I can do with those? No, there's not, so I can drop my parenthesis. I have a negative in front of my parentheses, so I need to distribute a negative 1, which would leave me with positive 2. I'm just changing my signs, minus 20i. From here, again, I can combine like terms, so negative 30 and positive 2 would get me negative 28. I can have the positive I and the negative 20i, add those together, would get me negative 19i, and I am done. Okay? Hopefully you're starting to catch on to this. It shouldn't be overly difficult. Now, multiplying with imaginary numbers is a little bit different. I can multiply a non-imaginary number with an imaginary number pretty much anytime I want. So 2i times 9, I'm just going to multiply the 2 and the 9. That would be 18. Bring the I along. I'm done. I have 12i times a negative 10. So again, I'm just going to multiply the 12 times the negative 10, which is negative 120i, and I'm done. 5i times 8i. This one's a little bit different. Think about if I had, you don't need to write this down, but 5x times 8x. How would I handle that? Well, it would be the 5 times the 8 would get me 40. X times x would get me x squared, right? We're going to do the same exact thing with the I. And earlier we realized something about I squared. We'll talk about that in a second. So I'm going to multiply the 5 times the 8. That'd give me 40. I'm going to multiply the I times the I. That would be I squared. If you remember from the front side of our paper, I squared is actually equal to something. What was it equal to? Well, it was equal to negative 1. So 40 times negative 1 would be negative 40. And I am done. On to number 14. I have 2 times the quantity 7 minus 6i. Here what I'm going to do is distribute the 2 to both. That would give me 14 minus 12i. Nothing more I can do to combine like terms. So it is over. 15, be careful here. 3i times 4 would get me 12i. 3i times 9i would get me positive 27i squared. Again, I squared equals something. So I'd have 12i plus 27. What does I squared equal? Negative 1. That would leave me with 12i minus 27. Do I want to write my expression with the I in front? Look back at the top. It will tell you no. So I need 27 plus 12i. And I am done. On to number 16. I have 1/2 I. I'm going to distribute that by 12. So 1/2 of 12 would be 6i. 1/2 of negative 6i would be negative 3i squared because I'm multiplying I times I. Again, I squared means something, so I'd have 6i minus 3 times negative 1. Well, negative 3 times negative 1 would get me a positive 3. So 6i plus 3. Again, I want anything that's attached to the I in the back. So it'd be 3 plus 6i. I'm done. Now on to 17 and 18. 17 and 18 kind of have something to do with what we did when we talked about factoring. This is double distribution. We talked a little bit about that when we were factoring, but it is review. So I'll take the 2 times the 7 and the 2 times the 8i. I'll take the negative 5i times the 7 and the negative 5i times the 8i. Well, 2 times 7 would be 14. 2 times 8i would be positive 16i. Negative 5i minus or times 7 would be negative 35i. And negative 5i times positive 8i would be negative 40i squared. So from here, I want to go ahead and combine all like terms. So I'd have 14. It'd be 16i minus 35i. Well, 16i minus 35i would get me negative 19i. Minus 40 times I squared is negative 1. So this would be 14 minus 19i plus 40. 14 plus 40 would get me 54 minus 19i. And I am finished. On to 18. I would have 1 times 3. That would give me 3. 1 times 5i would get me positive 5i. 4i times 3 would get me positive 12i. And 4i times 5i would get me positive 20i squared. Again, I need to combine like terms. So it'd be 3. 5i plus 12i would be 17i. 20 times I squared. Well, I squared means something. It means negative 1. So it would be 3 plus 17i minus 20. 3 minus 20 would be negative 17 plus 17i. And I am done because, again, I cannot combine something without an I to something with an I. That is the end of our lesson. The most important things here are to remember that the square root of negative 1 is an imaginary number that we call I. That when we are adding or subtracting with I involved, I can only add or subtract those numbers that have I attached to them. Treat it just like a variable. And when I'm multiplying, I can multiply the numbers even if they don't both have I's. Also remember that I squared will equal negative 1, and if you understand all of those things, you should be good from this lesson. If you have any questions, please make sure you ask, and have a great day.